Let's deep dive into graph today, and we are going to look at the problem if path exists in a graph or not. So I have already explained this problem in other videos. So if you go in playlist logic building, you can find this video. So there are two videos. One is in Golang and other is for Java. So first go there and try to understand, and if you find any issues you can come back here, and this is going to be long video, and I'm going to use Golang as a programming language here, and we'll deep dive into this and try to understand this problem. So what is this problem? It's a find if path exists in a graph. So this is a bidirectional graph, and in this bidirectional graph we want to check whether some path exists or not. So this graph is represented with this edge. So if you see edge here 0 to 1, so that means there is a path between 0 to 1, and also there is a path from 1 to 0. So this is bidirectional. 1 to 2, so there is a path from 1 to 2 and 2 to 1. And in the similar way 2 to 0, there is a path from 2 to 0 and 0 to 2. And there's a source 0 and destination 2. So we want to check if the path exists from vertex 0 to 2. So we know there is a path, and there is another path, so 0 1 2 and 0 to 2. So if path exists, then we can return true, otherwise false. So the first challenge here in the graph is to decide how to create a graph, how to represent these edges in a data structure. So we can do using array also, but I find very easy using map. So I'll use the map and represent this data as a graph. The way we represent this as a graph in a map is we create a map using these vertices. So we'll say 0 is a key, and in a value we can put 1 2. And in the similar way we can create another key 1, and we can create a value 0 2. So that means from 1 there is a path to 0 and also to 2. So that is the first thing we are supposed to do. So let's understand this. Let me copy this example. So step 1 here is create graph, and I'm going to use map to create the graph. So in the map, once I create this graph and put this data in a map looks like this: 0, and 0 is the key, and the value will be 1 comma 2, and then another vertex 1 as a key, and the value will be 2 and 0, and the 2, and the value will be 0 and 1. So if I can put data in this way in a map, that represents graph. So we can clearly see there is a path from 0 to 1 and 2. So that's why 0 is a key and the value will be 1 and 2. In the similar way, from the vertex 1 there is a path 1 to 0, and there is another path 1 to 2. So from 1 there is a 2 and 0. So this is a bidirectional. So if we can put 0 or 2 or 2 or 0, that's fine. Yeah, so the first step is create the graph. So we'll first create the graph and see this data structure. Second step is we need breadth first search, BFS, and we know in a BFS we need Q. So we'll use the BFS. And also step 3, we also create a array of visited. So we need first how many how many vertices are here. So there are 3 vertices, so we can create a visited array for length 3, and we can track whether this vertex is visited or not. So first thing, we'll start from the source, and our source is 0. So okay, we can make it visited, and for the 0 key we can find two another vertices 1 and 2 from the map, because from the 0 there is a path to 1 and also to 2. So there are 2 paths, so we'll get it 1 and 2, and then again from 1. So in this way, this is the BFS. So from 1 again we can reach to 0 and 2, and as soon as we reach to one vertex we can mark it true. We can come here, we can mark it true, we can also mark it true, and we can true, or we can say it's visited. So as soon as the source and destination is visited, we can return true. That means we find path, we can see the path. Otherwise we can return false. So that's the strategy, and let's write the code and try to print this graph in a map and see whether we are getting this kind of data or not. So let me copy this. We'll create edges, zero, 1, and so 1, 2, and last one is 2, 0. Okay, so we create the edges, and the source is 0, destination is 2. We'll call this function, and we can pass edges, we can pass source, we can pass destination. And we can print this result. So it can either return true or false. So for this example, it should return true. So come here and define this function. Let's create the map first for the graph representation. So map is map, and key will be int, and value will be array of int. We'll traverse the edge for edge. So in this edge will contain 0, 1, 0, 1, 2, 2, 0. So there will be in edge is another array which have index 0 and 1. Okay, so in a map we want first we'll get the edge. So from edge 0, if I say edge 0, I can do edge 0 or 1 because there will be only 2 items. So in a map at 0 I want to store this 1. So first thing edge 0, I will get the first thing is I'm going to get edge 0 value from the map. So in the beginning, the map edge 0 will have nothing here. So age 0 because that doesn't exist. And here I'm going to append and I'm going to put the value this 1. So how can I reach 1? So I can say age 1. Age 1. So if I leave this just one line, that will be one directional graph. Let's check that first. fmt m. Let's return something here. Let's return false. So map, and we can see the 0 from 0 to, there's a path from 0 to 1. Let's represent this map here. It's 0, 1 and 2. So if you see this map, so there's a path from 0 to 1. So 0 to 1, and then also from 1 to 2. So 1 to 2 and 2 to 0, 2 to 0. So in this way, this is the one directional graph, but we want to make it bi-directional. So in order to make it bi-directional, we also want to store this path from 1, 0. So we can make 1 as a key and 0 as a value. So let's copy this, make it 1. So that's 1. I will make a key, and if there is a item at 1, we get the item and append the 0 item. So that is a second item there. So now it becomes bi-directional. Let's print this. Okay, now we can see 0. From 0, there's a path 1 and 2. So from the 0, path 1 and 2, and from 1, 0, 2, from 1, 0 and 2, and from 2, 1 and 0, 2, 1 and 0. Okay, so once we understand this this data structure, like this data structure is how we can put whole graph in a map, then half of our solution is done. So that is the biggest challenge in any graph things. So we have to first decide how to store this graph structure in a map or array or some other way. So we are good for this. Okay, let's print it. There's nothing. Okay, okay, what is the next step? So next step is we want to use the BFS, and we also want to create this visited variable. So let's do that. So first I want to create this visited, and the length should be the number of vertex. So a number of vertex we can pass, or in age there are 3 rows, we can calculate this length. So that is length of edges. So we can do something like this. Make array of boolean, and the length is length of edges. So we can create the visited. Now every vertices the value is false by default, and we have the source. So first thing is we can put this source in a queue. So let's create the queue. So for the queue, let's create the queue. And we store this source in a queue. Push back, and that is source. So we know the source is 0, and we can create the two variables, age source visited, and we can make it true because we know we have already put this source in a queue, so that means it's a visited. Or let's follow this way. First, initially just make it false, age source visited and age is destination visited. So both make it false. And we can check, we know that we have there is a item in a queue, so queue is not empty, so we can check that conditions here in a for loop. So queue dot length not equal to 0, then come here and they get the item, first get the item from queue, so remove the item, one item from the queue, so always from the first, like front, queue dot front and then queue dot remove, and let's say it's element, and typecast this or convert this because that returns interface. So I can say this item element, I know it's a type is int. So the first we have put source in a queue, so we got this source here, and then we can check if the source is or this item is visited or not. So before that, like this item is 0, so we want to get all the items, like all the path from the 0. So we know all the path is in map, so from the map I want to get this item. So it's a key for key value and range as a map object is m, and here I want to put item. So we know we got one item from the queue, so we had put the 0. So from the 0, if I put the 0 here, from map I can get 1 and 2. Okay, so when I get this key here, so we do not care the key here, but so m item, so in a m item we put this key and we get, we put the 0 and we get 1 and 2, 1 and 2. So that's the p here, the value 1 and 2, and we can check if visited v, like if it is not visited, so visited v is a false. So if it's false, then we can first mark it visited v equal to true, and we can also push back this thing to queue. So queue push back v item, that is 1 here, and we did this, and we can check conditions here, like if visited source, so that is a visited boolean variables, and we know we want to check the source and destination is visited or not. If they are visited, we want to return true. So that's why I'm going to check whether source is visited or not. So inside the visited I put the source and I can check if it is true. So if it is true, then this variable we can make it true, and in the similar way I can check for the destination. And I can say is destination visited. So we check here if the source is visited, and we make it true. If destination is visited, we made it true, and if both conditions are true, we can return true. So if is source visited and is destination visited, then return true. Otherwise, anyway, we are returning false. So we are expecting true here. If it doesn't return true, then we can debug this. Okay, there is syntax error 46, not enough arguments. Okay, where is the 46? Q. Okay, so the way is q dot remove, and then from where we remove, from front, because this is the q nature. Okay, so return true, so that means it's good. Okay, so that's all for today. Thank you.